Okay, as an extension of yesterday's discussion, I will cover some examples to find the center of mass of extended objects. Afterwards, we will go to the velocity, acceleration, etc. of center of mass. So, let us derive some expressions for center of mass of some extended objects. Let us take a wire which is bent in the form of a semicircular ring of radius r. A wire is bent in the form of a semicircular ring of radius r. Let us try to find center of mass of this. Suppose mass of this is m, mass of this ring is m. For convenience, let us take this ring in the coordinate axis as shown here. So, you will have only y coordinate for the center of mass, x coordinate automatically becomes 0, because center of mass lies on the axis of the ring. You can have only y coordinate, x coordinate is set 0 here. Now, to find y coordinate, first of all, let us see what is the relation we are using. The general relation as derived yesterday is y center of mass for an extended object is 1 by m integral y dm. This is the formula for extended objects y coordinate. So, we will apply this for this case also. As I told you already yesterday, first you should find dm. To find dm, we take an element here which is making an angle d theta at the center. This element is making an angle d theta at the center. Now, the length of this element is equal to r d theta. Length of this element must be equal to radius into angle r d theta. So, mass of that element dm is equal to length of the element into mass per unit length. So, length of the element is r d theta multiplied by mass per unit length means we have taken the mass of the ring as m. So, mass per unit length means mass by pi r, because pi r is total length of the ring which is semicircular. Total mass is taken as m. So, mass per unit length will be m by pi r. So, mass per unit length into length of this element will give you dm. Now, let us apply this value in this relation. ycm is equal to 1 by m integral y into r d theta into m by pi r. Now, r gets cancelled, you will have m also gets cancelled. What is left out here is integral y 1 by pi integral y d theta. This is the thing you have to work out from 0 to r. Limits are from 0 to r. Now, let us see what is the value of y. Actually, element is chosen at a height y from the x axis. So, this is y. If this angle is theta, in this triangle sin theta will be equal to opposite by hypotenuse, that is y by r. So, y is equal to r sin theta. Substitute the value of y equal to r sin theta here, 1 by pi integral r sin theta d theta from 0 to r. Actually, here the limits will change because we expressed the value of y in terms of theta. Automatically, the limits will become 0 to pi, because you have to cover the total semicircular ring. The angle will be 0 to pi. So, this is equal to 1 by pi integral r will come out, r by pi integral sin theta is minus cos theta and limits are 0 to pi, which will be equal to 2. This will be equal to 2r by pi. So that would be the center of mass y coordinate when you arrange the ring like this. So for this ring, x coordinate is 0, x center of mass is 0, y center of mass is equal to 2r by pi. 2r by pi. This is how you will find the center of mass for a semicircular ring. Now let us use this result and try to find the center of mass of a semicircular plate. Let us try to find the center of mass for a semicircular plate using the result of the semicircular ring. Remember, for semicircular ring, center of mass will be on the axis at a distance 2r by pi. If this is the axis, at a distance 2r by pi from here, you will have the center of mass. That's why you have the y coordinate equal to 2r by pi. Of course, x coordinate is 0 because this is only on the y axis, x coordinate is 0. Now let us extend this result to a semicircular plate. If you take a semicircular plate of radius r, let this be the semicircular plate of radius r. To find the center of mass of this also, you choose the axis like this. This is x axis, this is y axis. Definitely center of mass will lie on the axis of symmetry. That's why x coordinate is automatically made 0. Here also, only thing you have to find is y coordinate. To find the y coordinate of center of mass, let us use the previous result, that is the semicircular rings result. For that purpose, you choose a small circular, semicircular element like this, whose thickness is dy or dr. This thickness is dr. Let the radius of this be r. We have chosen a semicircular part of radius small r and thickness dr. Its center of mass will be at a distance 2r by pi from this point. From the previous result, you can say that for this element, for this semicircular element, center of mass will be at a distance 2r by pi from this point O or origin. From origin, the center of mass of this semicircular element will be at a distance 2r by pi. Now, what is the mass of this element? Dm. Because for every case in the determination of center of mass, you always need dm. Here also let us find dm. Dm means area of this into mass per unit area. Suppose mass of this semicircular plate is m. Mass of the semicircular plate is m. Then mass per unit area will become m by pi r square by 2. Because circle area is pi r square, semicircular plate area will be pi r square by 2. So mass per unit area will be mass of the plate by area of the plate, semicircular plate. This is equal to 2m by pi r square. 2m by pi r square is the mass per unit length of the semicircular plate, and the element that we have selected has area pi r into dr. Pi r is length of this into dr is thickness, that will become area. Area into mass per unit area will give us dm of this element. So you can cancel pi here. This will be equal to 2m by r square into r dr. 2m by r square into r dr is dm. As usual, center of mass y coordinate is equal to 1 by m integral y dm, because we are expecting the center of mass to be on the y-axis, x coordinate is 0. Only thing you have to find is y coordinate of center of mass, which can be found by using this relation 1 by m into integral y dm. This is equal to 1 by m into integral y means where this element mass is located. Here you should be careful. The mass of this element is dm, but this dm center of mass is here. Because of the previous result, you can have center of mass of this semicircular part at a distance 2r by pi from O. Therefore, y coordinate of this y value should be equal to 2r by pi into dm will be equal to 2m by r square into r dr, and the limit of y is from 0 to r. This is equal to 1 by m integral 2 into 2, 4 will come here, 4m integral, in the denominator pi will come, r square dr by r square. R into r square, dr will be here, gets cancelled. Then what we are left with is 4 by pi r square into integral r square dr from 0 to r. This will be equal to r cube by 4 by pi r square. This is equal to 4 by pi r square into r cube by 3. So, this will be equal to 4r by 3 pi. So, for a semicircular plate, center of mass will be at a distance 4r by 3 pi from this point. For a semicircular plate, if this is a semicircular plate, the center of mass will be at a distance 4r by 3 pi from this point O. X coordinate is 0. X coordinate will be 0, y coordinate will be 4r by 3 pi. XCM is 0, YCM is 4r by 3. XCM is 0 because this is taken symmetrically about y axis only.